we are going to have the class from the organic chemistry. So JEE Advanced, nothing but from the organic chemistry is very, very important in organic chemistry point of view. So coming to our first question. So what is that? The major product of the following reaction is. So it is nothing but we can see that it is the orthomethyl phenol. And this orthomethyl phenol reaction with aqueous NaOH and on reaction with methyl iodide. So what is the product formation? So first of all, this sodium hydroxide. What is nothing but this will form as Na plus and OH minus. Now here phenoxide ion formation will be there and it will form the intermediate product like this. So this is the intermediate product ONA. Yes, so orthomethyl sodium phenoxide ion. So now this one on reaction with methyl iodide. So we know that Williamson's ether synthesis. What is Williamson's ether synthesis? Williamson's ether synthesis. In that what happens? That sodium or nothing but sodium methoxide ion or sodium alkoxide ion will react with the alkyl halides to form nothing but our ether. So here also what happens? Nothing but this NaAI will leave out and the formation of our, you can say that is what orthomethyl anisole formation will be there. So our answer is nothing but C option, orthomethyl anisole. So nothing but here you have to see the mechanisms of the reactions and how the product formations are taking place. Simply you can get the product and all those things. Clear? Next one. So moving on to the next one, the major product of the following reaction. So we are having one bromine atom attached to the benzene ring and the other bromine atom which is attached to the chain which is attached to the benzene ring. Now in these two, which is more reactive comparatively? If you can see, this bromine nothing but is having a lone pair of electrons. So this lone pair of electrons will be involved in the nothing but resonance formation. So this is not reactive. But coming to here, this bromine is not involved in any resonance. So what happens here? This KOH in presence of aqueous KOH, we know the substitution will take place. So substitution will take place. So I can say this one OH. Yes. Now CrO3 in presence of H plus. So CrO3 is nothing but which type of agent is called as oxidizing agent. It will convert the alcoholic group to the carboxylic group. So I will get like this. OH, yes. And here hydrogen atom will be there. Now what is that? What is saying? In presence of H2SO4. So in presence of H2SO4, what is that? H2SO4 is a dehydrating agent. So it will remove the what is that water molecule to form the product as our this one. So this is the product formation will be there in the presence in this reaction. So here you have to see that two bromine atoms are there. In this, which bromine atoms will be substituted by the aqueous KOH group and then undergoing oxidation, which is CrO3 nothing but is a strong oxidizing agent. So in presence of strong oxidizing agent, the alcoholic group changes into the carboxylic group, and then H2SO4, which is nothing but a dehydrating agent, removal of water molecule will take place, and you will get a cyclic product like this. Okay, moving on to the third question. So next, the major product of the following reaction. So here we are having one benzene ring, and this benzene ring one alkene is attached, cycloalkene is attached. So bromine nothing but it will attack on the cycloalkene ring. So two bromine atoms attached like this. Now what is this? In presence of ethyl alcohol, so ETOH. So HBr will be released. Now bromine will release from this carbon or from this carbon. So if suppose it is releasing from this carbon, it is forming a what is that secondary carbohydrate. If it is releasing from this carbon, it is forming a allyl carbohydrate. Now between allyl and secondary, which one is more stable? Allyl carbohydrate is more stable. So this bromine will be released and OET will be substituted on this carbon. So we will get the product as like this. Okay, so nothing but we can see that our product is our D option. Next one, the major product of the following reaction. So the major product of the following reaction. So here phenolic group is present, OH group is present, and SO3 group, SO3H group is present. This one is a plus M group, and this one is a minus M group, as well as a good leaving group. Okay, So now, first of all, this phenol on reaction with bromine, it will form 2,4 like this. So now two bromine groups are attached at two or substituted at two ortho positions. Now, since I am saying that SO3H is a good leaving group, so it will leave the group in presence of another bromine atom, bromine molecule to form our compound is like this. So 2,4,6 tribromo phenol formation. So I can say that our Q option is nothing but the correct answer. So B. So 2,4,6 tribromo phenol formation is there. Next, in the reaction, the intermediate is or are. So first of all, we will find what happens in presence of NaOH. Already I said will form ONA. Okay. Now OH is a, what is that? Orthopara substituting group. So bromine will be substituted here. Or I will write this one as like this. Okay. Now I can write this one as O minus group without writing ONA. So what happens? Now this formation will be there. So double bond, double bond, double bond. Oh, here negative charge will be there and bromine atom. Again, this negative charge will go there and this will have coming here. So double bond, oh, bromine and negative charge. So now here already when we are having bromine plus is there. So this bromine plus will attach on this carbon to form or substitute on this carbon to form our product or the intermediate product, we can say that. So this is the intermediate product formation will be there in this reaction. So answer is nothing but our B option we can see. Next, read the following question, answer as per the direction given below. So some statements are given that with bromobenzene upon reaction with bromine in presence of iron gives 1,4 dibromobenzene as the benzene as the major product. Okay, generally bromobenzene. So bromine on a benzene, it is generally a minus I group, but a plus M group. Now, when the two effects, the inductive effect as well as the mesomeric effect takes place simultaneously on a molecule, then mesomeric effect predominates than the inductive effect. So if I am reacting with iron in presence of bromine, I will get this one as a major product. Okay, so here what happens, nothing but at ortho position also the minor product will be, this will be the minor product, but due to the same groups or same atoms are attached, there will be repulsion between these molecules. So this is the minor product, like I say, and this is the major product. So in iron in presence of bromine, we will get what is that 1,4 dibromine. So statement 1, I can say it is correct. Okay, this one is correct. Next one, in bromobenzene, the inductive effect of the bromo group is more dominant in the mesomeric effect, directing the incoming electrophile. No, what happens, nothing but bromobenzene, in bromobenzene, mesomeric effect predominates than the mesomeric effect predominates than inductive. So that's why we are getting 1,4 dibromobenzene as the major product. If it is a, if inductive effect predominates, then you will not get the 1,4 dibromobenzene as the major product. So that's why we can say that statement 1 is true, but statement 2 is false. So we can say option C is correct. Statement 1 is correct, and statement 2 is incorrect. Next, the number of resonance structures for N is. So here I will get the product as so already I said in presence of sodium hydroxide, what happens? ONA formation will be there. Now, giving all the resonance structures like this, you will get totally 9 resonance structures are possible for this compound. If you draw all the structures, you will get 9 resonance structures which are formed by this compound. Okay. Next one. So Riemann-Tiemann reaction introduce an aldehyde group onto the aromatic ring of phenol, ortho to the hydroxy group. This reaction involves electrophilic aromatic substitution. This is a general method for the synthesis of substituted salicylaldehyde as depicted below. Okay, so Riemann-Tiemann reaction generally it is formation of salicylaldehyde from phenol. Now let's see. So here one methyl group is here, so we are getting salicylaldehyde. Okay, no problem. So what is the question now? The structure of the intermediate one is. So this is the one. So what is the structure of this one? So in Riemann-Tiemann reaction, what happens? Nothing but here the reactant is CHCl3 in presence of NaOH. CHCl3 in presence of NaOH. So what happens is here nothing but we can say that here OH CH3 now in presence of aqueous NaOH. So first of all, I will get this one ONaCH3. Now in presence of CHCl3, here what happens? HCl will be lost and I will get ONaCHCl2. The hydrogen from here will go to this carbon. We will getting CHCl2 and here CH3 is there. And on reaction with aqueous HCl, we will get the product as OH CH3 CH2. Nothing but paramethyl salicylaldehyde, orthohydroxy paramethyl salicylaldehyde we are getting. Yes. So now let's see what is the question. Structure of the intermediate IE. So intermediate IE is nothing but our, what is that? CCl2 is the intermediate which will attach on this carbon. Okay. So CCl2 will give. So we are getting as CHCl2. So I can say that this is the B option is our intermediate ONA in presence of CHCl2 CH3. Next, the electrophile involved in the reaction. So what I am saying that CHCl3 plus NaOH, what happens? Nothing but here formation of CCl2 dichlorocarbene will take place, and this is our intermediate. So what is that? CCl2 dichlorocarbene is the intermediate in the reaction. And next, which one of the following reagents is used in the above reaction? So already we have seen what is the reagent we are using. Aqueous NaOH in presence of chloroform. So I am getting aqueous NaOH in presence of chloroform is our what is it? Reagent in the above reaction. Okay. So these are nothing but organic chemistry involves easy questions, but we need to know how to write the mechanisms of the reaction and how the electron flow will take place, how the electron flow from suppose double bond to single bond, how it is taking place, and from how nucleophilic addition will take place, or how electrophilic addition will take place, how electrophilic substitution will take place, nucleophilic substitution will take place, and all these things you have to know. Then only organic chemistry will be simple to you. Okay, guys. So tomorrow we will have the physical chemistry questions. So physical chemistry is also very, very important for the advanced point of view. Whether we are having first of all organic chemistry and then physical chemistry. Physical chemistry is also very, means if we have some equal weightage of the organic chemistry. Okay. So thank you very much.